speaker. And today is a special day. The Nobel Prize was given to black holes specifically. I mean, it was given to LIGO for discovering gravitational waves from black hole mergers, but today is special in the sense that it's focused on black holes. And it's a special day for the Black Hole Initiative because we recognize that this is an important frontier 4 years ago, and now we are being vindicated. You know, 2 Nobel Prizes after 4 years related to black holes. That implies that it's a very exciting frontier, a frontier for the future. And it's quite remarkable that in 1939, about 80 years ago, Albert Einstein wrote a paper in Annals of Mathematics where he argued that black holes may not exist. Even though, you know, Carl Schwarzschild derived his solution, he thought that they might be mathematical curiosities. And one of the things that Roger Penrose did together with Stephen Hawking was to demonstrate that they are a robust prediction of general relativity, and that you should find them in the real universe. And indeed, that this work was done in the 60s, both Penrose and Hawking. And around that time, quasars were discovered, 1965, and that led to the recognition that black holes may in fact exist, and later on, stellar mass black holes in X-ray binaries and so forth, and in the early 70s. You know, Penrose had many important contributions. Penrose diagrams of space-times, the Penrose process of extracting energy from a black hole, the cosmic censorship hypothesis. But even beyond black holes, he did important work on in mathematics, Penrose tiling and the twistor theory. So he is definitely a very broad range intellectual that contributed in many aspects of science, and richly deserves the prize, no doubt about it. It's quite likely that if Hawking was alive, he would have been a very strong contender this year. Stephen Hawking unfortunately passed away more than 2 years ago. The observational work by Reinhard Genzel and Andrea Ghez was revolutionary in demonstrating that the supermassive black hole, Sagittarius A star, exists at the center of the Milky Way and weighs 4 million solar masses. They monitored the motion of stars and demonstrated that, and not only measured the mass, but also are testing Einstein's theory of gravity this way. The two teams, I should say, there are 2 interesting points. The 2 teams were very competitive with each other. You would see them giving talks back to back at conferences, and not necessarily always nice to each other's, but always competitive and always roughly at the same level. And to me, it's a great demonstration that the competition is very good for science if it's done constructively, if it's done in the way that the 2 teams did it, where they basically tried to excel and do better than the other team. And that lifted their level of excellence at the same time. And they always sort of hovered at the same level. And so they are richly, you know, both of them, Andrea Ghez and Reinhard Genzel, deserve it very richly. Another point about Andrea is that she's the 4th woman to get it since 1903, to get the physics prize. And we need many more women to be awarded the prize, of course. And she's a great role model for a young, highly professional and highly accomplished scientist. And so that is a great recognition as well. And so we are really delighted that all 3 received the Nobel Prize today. And it's, again, remarkable that 3 out of the 4 prizes in the past 4 years overlapped with astrophysics. And with this, I would like to let either Achilles or Fabio introduce our speaker today.
Okay, so today is our great pleasure to have Lisa Messeri with us. Lisa Messeri is an assistant professor of sociocultural anthropology at Yale University, and she's also affiliated with the program in history of science and medicine. Before joining Yale in 2017, she was a faculty in the program of Science, Technology, and Society at the University of Virginia, where she taught STS, so Science, Technology, and Society, to engineering students. She earned her PhD from MIT, and where she also earned a Bachelor in Aerospace Engineering. And she's an anthropologist of science and technology, and her research examines the role of place in the scientific practices and technology development. So please, Lisa Messeri, take it away.
Thank you so much. Thank you for the invitation to come speak with you all. I'm just going to quickly share my screen and start my presentation. Can you see the slide? A little nod?
Yeah.
Perfect. Okay. Great. So yeah, thank you all for tuning in today. And yeah, this promises to be something a little bit different. And I'm very much looking forward to the conversation that will follow afterwards, in addition. So last week, last Tuesday night, actually, about a week from today, as this current moment affords, I zoomed into a class in Chile of a group of students studying for their master's in architecture. And they had read my book that I'll talk about in a second, and were actually saw a version of the talk I'm about to give. And during the question and answering period, one of the students asked what I thought about the similarity between the image of the black hole in the movie Interstellar and the Event Horizon telescope image, or other recent NASA images, all of which I've kind of presented here as a little constellation. So a week ago, I answered that I actually didn't have any thoughts, but by next week, when I was giving this talk, I would. So that's actually my way of saying that black holes are definitely not my area of expertise. I, in fact, was giving myself a crash course in this topic over the past week to prepare for this talk, and was really grateful to watch many of the recorded presentations that were on the BHI website, including, of course, the press release when the image was released in 2019. And I also caught up on Peter Gallison's YIP lecture to see what the conversation about these images was looking like, so that I could help continue along that conversation to build it and to grow it. So I'm actually not going to presume that I will offer anything new to say about these images, or of course black holes images more generally, that perhaps than any of you in this room or attending have thought of. And what my intention is instead is to kind of tee up a set of questions that I personally, after a week of intense study, have about black hole images, and also to offer a parallel case study that's a bit closer to my area of expertise that might help us collectively brainstorm what to make of images like these. So I've titled the talk Astronomical Images and Imaginations, and we have a, let me just get the thing going, there we go. Of course, there's the image that you all in this room are familiar with. There's the imagination that comes from a movie like Interstellar. And of course, there's this question of what exactly is that third image, this NASA simulation that came out around, a little bit after, I believe, the EHT image. Is this image or imagination? So I'm going to return to these three images at the end of the talk and kind of open up what I think an anthropological analysis of these images might look like. But first, I'm going to introduce you to my kind of research more generally, and perhaps answer one of the questions you might have, which is, what exactly is an anthropology of astronomy? And perhaps why is there an anthropology of astronomy? And to give it just a very brief introduction, myself and my colleagues in anthropology of science and technology more generally study the practices of contemporary scientists by being in close conversation with a particular scientific subdiscipline. To give it the kind of anthropological takeaway, myself in particular, I'm really interested in how scientists make meaningful these distant and invisible objects that are the occupation of astronomers and cosmologists. And moreover, I try to tie it to how this, astronomy kind of enriches our understanding of what it is to be human and what it is to be in the world. So to be an anthropologist thinking about and thinking alongside astronomers is to really be, as always, what the anthropologist is always asking about is the human, and what is the human's role in the world or the universe more broadly. And my main kind of take on this is in my book, which came out in 2016, in which I worked alongside exoplanet astronomers and Mars scientists, and really focused on how, through scientific work, planets shifted from being scientific objects into worlds, and how that in turn help us to think today, in the age of the Anthropocene, et cetera, how to think about Earth as a planet and also a place. So in the talk that I'm giving, that I'm offering as a parallel case study, I'm going to be talking particularly about exoplanet astronomers, precisely because this quest to understand the invisible, the mysterious, strikes me as quite of a piece with black hole research more broadly. And also, this is the piece of research that I did quite close to home to the BHI. I was a graduate student at MIT, and I worked primarily with Sarah Seeger and her research group for the exoplanet part of my work, as well as Deborah Fisher, while she was a visiting scholar at the Radcliffe Institute, that also overlapped with when I was carrying out most of my field work. Now, this field work that I did when I was in intense conversation with Seeger and Fisher and others was at this point a decade ago. And my current research is on virtual reality. And so while I've kept up with Exoplanet in terms of reading, some articles that come across my desk, or of course press releases, I am not as embedded in the field as I once was. So kind of take that with a grain of salt. But I think what stands is the analysis I'm about to offer in terms of the kind of evolution and the way of thinking about exoplanet imagery and images over both the period I did my fieldwork, but as a trend that continues very much to today. So yeah, I'm going to talk about the way image and imagination works in the field, and hope that this will open up to a conversation about parallels with black hole research. So this is kind of the schema that I use for thinking about the interplay of different exoplanet images and imaginations. And again, the shift by which an exoplanet becomes a world. I'll be walking through this entangling between image and imagination with the focus on kind of this placemaking or world making that I think image practices, both scientific and public facing, are really key in understanding. As I'm sure those of you in the room are tuning in kind of know, that exoplanet astronomy is, the study of invisible worlds. There have been over 4,000 discovered, and a lot of the research is really focused on finding what is considered to be an Earth-like exoplanet. So all of the images that are on this slide are of the same planet, the same exoplanet. They're all of TRAPPIST, from the TRAPPIST system, and all of TRAPPIST 1F, or the bottom one is TRAPPIST 1E. And this made a big news splash when it was discovered in 2017, because this was a system that contained not one potential Earth-like planet, but many potential Earth-like planets. And so really captured the imagination of what are the conditions of life as we know it across the galaxy. So I'm going to talk about these three categories of scientific images, the scientific, the artistic, and what I call the touristic. And I'm going to spend the briefest time on the scientific image, as I'm sure you all know a bit more about that, and instead try to give some background for the artistic and touristic images. So I did spend a lot of time in my research as I worked with exoplanet astronomers, understanding how they produce scientific images, the kind of images that circulated in scientific papers. And, when I would interview and talk with exoplanet astronomers and ask them, like, what is their imagination of an exoplanet, they would always say, this is what an exoplanet looks like, and hold up a light curve or a radial velocity graph. And I have a lot I could say about the production of these images, but perhaps for the sake of brevity, I will just draw your attention to the third chapter of my book, in which I really detail how these images are produced and what it means to be trained as an exoplanet astronomer to produce and understand and be able to read images like that. But what I want to point out is kind of the difference between the top set of images and the bottom set of images. So again, when I was doing my fieldwork, primarily between 2009 and 2011, which is already, of course, ages ago, there was scant data in terms of exoplanet observations. And yet there was a bunch of different representations. It was still in a disciplinary forming moment when the scientists I was working with were really developing a new visual language by which to communicate the tremendous progress that was being made in the fields. And the biggest tension that was really present during my fieldwork is, what do you do after you know you have found an exoplanet, when there is proof of this object's existence, and when you're wondering what that exoplanet is like? So the top images, particularly the first and the second, the light curve and the radial velocity graph, are evidences that an exoplanet exists. And it begins to tell you, looking at those images, some of the characteristics, what size it is, how it relates to its host star. But the bottom graph is where the fun really begins with the scientists I was working with. The bottom graphs are both trying to capture probability spaces. Given what little we know in terms of robustness of the characteristics of the planet, what kind of world might this be? What are the different atmospheric potentialities of an individual exoplanet? So what was important to me about scientific images and how it relates to the imaginations these scientists brought to the exoplanets they worked with was this tension between understanding that the data was not yet robust enough to fully articulate what kind of world it was, and yet this desire to imagine precisely that, to imagine as robustly as possible the worlds that the scientists I was working with was discovering. So there were ambiguities in the work that they were doing, and these ambiguities were represented in these like probabilistic spaces of what is on the second realm. Anyway, I could go on and on about that, but basically what I'm trying to show here is the tension within scientific image making between what is known and what is being imagined in terms of the kind of worlds these invisible exoplanets are. And the reason that's important to me in the context of this talk is that's in a real contrast to what happens when an artist is brought into the loop in terms of trying to depict what kind of worlds these are. And what you get is a shift from these kind of pragmatic scientific images, which allow for a multiplicity of kinds of worlds, into a more imaginative artistic image in which actually the ambiguity of the scientific images yield to a more singular understanding of the exoplanet, particularly when it comes to a broader circulation. So this is also, in shifting from the scientific to the artistic images, is a way in which these images move beyond the scientific conversation and circulate amongst broader audiences. So I looked at very briefly the work of one astronomical artist, Lynette Cook, who was part of doing the depictions for the first exoplanet that was discovered in 1995. And those are the folks who won the Nobel Prize last year, Quiluz and Mayor. And when she was working in the 90s as producing these artistic imaginations, she said how when she worked with scientists, they really were resistant to her using too much of her imagination. They wanted to really keep to what is known. So we see, for example, in this 1995 image, really what was known is it was a hot Jupiter, an exoplanet of large size orbiting close to the sun. And so we basically, in its shadow, we know very little about what this exoplanet is, but do know what would have been known from the data in terms of the distance between planet and sun, etc. So when Cook, this particular artist, wanted to evoke a particular kind of imagination of what the place of these exoplanets was, she was allowed by the scientists to draw the image of an exoplanet. So in this case, the exoplanet is the Saturn-like planet, but from the perspective of a moon. So here, the foreground, the kind of lava and the lava-soaked ground is not an exoplanet, but an exomoon. And there's absolutely no proof that this exomoon existed. And so the scientists were willing to let her have a little bit more latitude in depicting a more in-depth in place perspective. And Cook liked that because it allowed her to convey a sense of temperature that with just the exoplanet she couldn't quite do, particularly when it was primarily gas giants that were being discovered. But you know, we also see in this image a resonance with an earlier mode of astronomical art. And this is kind of very purposely evocative of Chesley Bonestell, who even before the space age was offering these artistic imaginations based on robust, you know, as precise as the scientific understanding was at the time, images of Saturn, for example, from the moon of Titan. But this aesthetic actually goes back even further. Before Bonestell, a lot of astronomical art is actually indebted to the Hudson River School and a mode of Western landscape painting, and particularly American landscape painting, that was meant to convey a sense of place and excitement to people back east, to East Coasters, kind of showing the great country that unfolded in the West. And so it's not hard. I'm not making too big of a connection here between the visual resonances of, say, Thomas Cole's The Subsiding of the Waters of the Deluge, and this image from 2017 by Tim Pyle of TRAPPIST-1F, the exoplanet that was discovered quite recently. The color, the shading, the color, even the role of water is deeply important here, because for Cole, saying water, subsiding of the waters of the deluge, here he was making a claim about the Edenic promise of the American West. And this idea, the role water is playing in this exoplanet image is very much the promise of an Earth-like exoplanet, one that can sustain life as we know it. So even beyond this visual resonance with landscape painting, where, you know, it's actually a landscape of an exoplanet, other scholars have drawn attention to how even the more abstract Hubble images evoke a sense of, evoke a feeling both in color and tone and also sublimity of the Hudson River School. And, you know, this is an argument I'm drawing from Elizabeth Kessler, who in her book, Picturing the Cosmos, interviewed those who are astronomers working with the Hubble Heritage Foundation project, and the way they approached the artistic work of producing the beautiful Hubble images that I'm sure have inspired many of us to, you know, pursue astronomy and get engaged with it. And what Kessler says, the significance of this aesthetic, according to Kessler, is, and this is briefly quoting her, through a reprisal of romantic tropes, the Hubble images once again invoke the sublime, and they encourage the viewer to experience the cosmos visually and rationally, to see the universe as simultaneously beyond humanity's grasp and within our systems of knowledge. And, you know, that very much captures, I think, a lot of work that these astronomical artistic images do, is they inspire awe, but because they are captured with our telescopes, suggest that this is an awe that we can come to have knowledge about. That is kind of what, when Burke writes about the sublime, that's exactly the power that sublime has over the human imagination. So Hubble images are present the cosmos as sublime, but precisely because it's this familiar aesthetic of landscape painting, they also present the universe as a knowable place. And so that's kind of that's all wrapped up in these artistic images of exoplanets. They have a history both in this American painterly tradition, but also with Hubble images and astronomical art traditions. So you'll note that since when Cook kind of was admonished by the astronomers that she worked with not to overly promise what kind of place an exoplanet is, you'll kind of see that the current norms of astronomical art, particularly exoplanet art, no longer adhere. We don't know much more about TRAPPIST-1F than, say, was known about 51 Pegasi when it was first, when that discovery was first announced. And yet the artistic imagination is allowed a lot more leverage in terms of the promise of what this system might hold in terms of finding an Earth-like exoplanet. But what I want to emphasize most is that there are really powerful acts of placemaking that go into transforming the light curve inset on this slide to the landscape that gets circulated as part of the press release. But also that this is not a new way of depicting or imagining outer space, but really has deep aesthetic histories. So we'll kind of go to the third image now, again, before drawing a connection back to black hole images. So if scientists kind of see worlds in data and artists are able to translate this imagination into landscapes, and exoplanets are thought of as worlds and places in this work, the question that got raised for me is, might these also be destinations? And this is where I began thinking of this particular genre of artistic images, of touristic images that suggest a human future of sorts, both futures for humans beyond Earth, but also perhaps a future for Earth itself. And so I draw inspiration from this series called Visions of the Future, which was produced by NASA JPL and began being published in 2016. And every time there's a cool discovery, they kind of pump out one of these posters depicting what they call imaginative travel destinations. And so just like the exoplanet artistic landscapes, these posters very much resonate with an older visual aesthetic, not the Hudson River Valley, but in this case, the 1930s and 40s Works Progress Administration posters. Now, the WPA had employed artists during the Great Depression to tempt the US car culture to kind of become a spending economy again. And the director of NASA JPL in 2015 or so saw one of these posters at the Grand Canyon while he was on vacation, and they had just released a whole bunch of them. And he took it back to JPL as inspiration for this series, basically saying, this is what exoplanets need. And we really see the direct resonance here. So in both, humans give scale to the scene. They're exploring together. They're kind of in awe at the wonder of science. Others kind of have this fantasy of the American frontier baked into the touristic image that's being produced. And most curiously, there's also a bit of childhood nostalgia wrapped into particularly the TRAPPIST series, which is asking us to, planet hop from TRAPPIST 1E, and you see what looks like a nuclear family of sorts kind of pressing up their window to the glass and looking out in amazement. So these visions of the future, I argue, are steeped in the past, both aesthetically in terms of the WPA style color blocking and format, but also symbolically. There's a white picket fence, appeal to the frontier, this idea of childhood vacations. So these are futures saturated with nostalgia. But nostalgia for what? What can exoplanets make us feel nostalgic about? And so of the thousands of exoplanets, these become posters because Kepler 186f, Kepler 16b, TRAPPIST 1e, these all are discoveries that have brought astronomers one step closer to discovering the hoped for Earth-like exoplanet. And so what is that Earth-like exoplanet? Well, it's a pristine planet that is like our own, but in its pristineness, it's untouched by pollution, unworried by politics, certainly not in the middle of a pandemic. So these posters evoke a nostalgia for Earth as we have never known it, or maybe Earth as we remember it from childhood. And so there is, in fact, one Earth poster, your oasis in space, where the air is free and the breathing is easy, where the exoplanet tourists eventually come home. And this is the only poster where the helmet is set aside. And very much with the water in the midground, this very much resonates with that Cole painting and this desire for a new Eden. Well, here is a remembrance that, the Edenic world we're looking for might be our own. And how do we in turn ensure that there is a future Earth to return to once we're an exoplanet faring species? So to bring back this to kind of an anthropological takeaway, the point I'm trying to make is that image practices in astronomy tell us something about our own world. And so likewise, image practices, I imagine, in black hole research also have something to tell us about our world, and our challenge will be to figure out what that is. So we're going to transition now to the black hole side of things, where really I'm hoping to open up a conversation. The case study that I'm offering of exoplanet astronomy shows us a process of world making by which we move from scientific to speculative images. And I'm wondering if there's kind of a parallel analysis that can be carried out with some of the more prominent black hole images that I've encountered. And these are all, of course, public facing images in a particular way. There's, of course, there's a lot of similarities between black hole research and exoplanets. They're invisible. I don't know, they're roughly spherical, right? They're certainly at much different scales, both gravitationally and geographically. But I also, in watching a bunch of the talks, I noticed that black hole scientists actually use a similar metaphor to explain to a lay audience the difficulty of their observational feats. Exoplanet astronomers often use the analogy of their work is trying to detect a firefly moving in front of a spotlight when the spotlight is in California and we're in Boston. The black hole analogy that I heard a bunch of times is apparently the same feet of distance, but reading the date on a quarter. As an anthropologist, I could probably write a whole article on the differences between those metaphors, but I just found that a fun resonance. And of course, exoplanets and black holes are these beautiful mysteries that inspire imaginations, that lend themselves to really thinking fantastically about these cosmic phenomenon. But what is the imagination of a black hole the imagination of? If you buy my analysis, exoplanet image making is about placemaking, making invisible planets into worlds. And this isn't too much of a stretch because, you know, we live on a planet, Earth, so it's already kind of easy to think about planets as world. Exoplanets lend themselves to a very analogous imagination. But what then is the black hole image making about? It's not place, but it's something else. And I'm going to offer a hypothesis based on my, 3 days of cramming all the information about black holes I could. But this is also where I'm going to be interested in hearing your thoughts. So here's my proposal. The image of black holes is about an imagination of movement, and perhaps, if we're allowed to stretch this in an anthropological way, even liveliness. When I was watching the press conferences and the few talks, so again, these are more or less public-facing discourse, I was really moved by such phrases. From example, during the press conference in 2019 from Avery Broderick that, quote, black holes are gravity run amok, and how the size and shape of the shadow in the image is determined by gravity alone. Or Shep describing the almost poetic journey of a photon from the black hole back to Earth and that final treacherous obstacle of getting through the atmosphere to our detectors. These are the photons, the ones that we see are the photons that escaped gravity's clutches. This is where I wonder if we can take that metaphor further. Not only does it escape gravity's clutches, but does this somehow speak to a particular kind of liveliness? These photons escape, they survive, they are liveliness. And even thinking about Interstellar, the black hole in that movie, I did not have a chance to rewatch it, so this is me trying to remember the plot beats of a Nolan movie, but I believe that the black hole is used as a slingshot, harnessing gravity to get Anne Hathaway's character back home alive. McConaughey's fate is different. He gets sucked into the black hole in the weird multiverse that opens up. But the image of these photons, the escape of Hathaway, this is movement, this is liveliness, this is living. And if I understand it, this image is also movement, right? The bright spots are the photons that are speeding towards us. The shadow or the dimmer spots are photons moving slower or moving away. So even in the still image, there is, particularly for the scientist who knows how to see it and knows how to understand what the image is telling us, there is movement, there is liveliness. And I was really struck in all these talks, the swirl of the accretion disk. And this is probably where you're going to really push back, but I figured I might as well offer some provocations at the end. To me, I couldn't help but thinking about the DNA, the double helix, kind of that swirling, and again, a sense and a call to liveliness. And And the NASA image, the artistic one, is it's actually a GIF, right? It's moving around. If you were to go to actually click on it, it's a simulation of what the photons are doing at the event horizon. So again, these are my preliminary thoughts, and I haven't done anthropological due diligence that I would need to fully support this. But I hope that my analysis of exoplanet images would first hopefully inspire some trust in me as a thinker about these topics, but then also open up this conversation about the kind of associative ideas that might be accompanying these black hole images. And the aspiration of thinking along these lines would really be to unlock a way of talking about the broader meaning behind this very fascinating scientific work. There's beautiful images of black holes being produced now. What are they an imagination of? So that's the question that I will end this talk on, and really look forward to your questions or comments.
Thank you, Lisa. Thank you, Lisa, for this beautiful and very special talk. So let's see if there are questions.
Is it okay to just ask a question, just straight out?
Sure, yeah. Mm-hmm.
Yeah, so I guess like for me, the thing about black holes that I always found kind of interesting is that they're sort of like, there's this idea of an event horizon. So they're kind of a boundary of the universe. And what they sort of remind me of, at least, is this idea of when people used to think that there was an edge of the world. Like the Earth was somehow finite and you'd kind of just like fall off the edge. The event horizon, or at least the shadow of the black hole, sort of reminds me of that.
I love that. And it similarly has this sense, I mean, so what does it mean to fall off the edge of the earth, right? Like, clearly I'm going to interpret all these comments as support of my hypothesis. So, you know, that falling off the edge of the earth, maybe it's the opposite, in fact, that you're on this like edge of liveliness and unliveliness, and that evokes such incredible images.
Yeah, we have a question from Peter.
Thank you for a very nice talk, Lisa. Thank you for joining us all. Sorry, it's not in person. I had two thoughts. One was that, there are many aspects of the Event Horizon Telescope image that are fixed by the data, but there were some things that were not. And one of them that was not was color. Color is something we had to make a decision about. And I remember very vividly discussions about whether, for instance, it should be in the blues or in the oranges. And so, some people said, well, the tip of a flame, the hottest part is blue. Maybe we should make it blue to indicate this is billion-degree Kelvin plasma circulating around the black hole that we're seeing. But orange is, if you put a decal on your refrigerator, you don't make an orange. And if you put one on your stove to warn people not to touch, you don't make it blue. So, but this comes to a larger point, which is that, as I think you indicated, that the images never travel alone. They always travel in swarms. And whether they're scientific images or technical images or artistic images, there's always a reference to other images, to a history and a contemporaneity of image making. And the decision to make it orange is in the light of all these other images that we have. We could have made it black and white also, right? I mean, it could have been just outside of color. The other thing about meaning, or the referentiality of the images, that I think is tremendously guiding, entrancing, unnerving for people who work in this field of black holes, is that they're fundamentally paradoxical objects, that they have this they are the darkest object, they don't reflect or emit light, but they're also the beacons of the largest, most intense brightness that we know of. And so we can see quasars powered by black holes from the farthest away that we're given access to in the universe. That they symbolize, the end state of stars in their smaller varieties, or of, the symbolism of a one-way membrane as a form of death, and the end state of things. But they're also responsible for clearing out the conditions in a galaxy to make galaxy and star formation possible. So they're kind of creative and destructive. And I think that is another aspect. And then, black holes, at least in their pre-quantum consideration, are, the simplest of objects. What can you say about a black hole? Mass, charge, spin, end of story. But then as we think about them as repositories of information, they're the most complex objects in the universe. So, this bright, dark, death, life, simple, complex, and the list goes on, I think gives them a particular feature, that they're not unambivalently anything. I mean, Freud once said that our default state, he didn't use that term, but the usual state of our emotions is ambivalence, not, something simpler. And that maybe these images activate us and entrance us because they are such ambivalent objects.
Thank you, Peter. That's really fantastic. And I love that idea of the ambivalence of the black hole, which of course I'm sure everyone assembled here feels very passionately about. And that was, as an anthropologist or a science studies scholar, my first question was, how are the colors chosen? So I'm really happy to have that answer. And actually that's what really struck me, because at first I thought it was going to be a kind of a correlation of heat, because that's how I'm used to thinking about those kinds of astronomical images. Like in Hubble, often the different colors have something to do with heat or the different gases, etc. And that's why I was really struck to learn that the lights and the darks are actually about movement, about kind of the photons moving near or moving away. But of course, this is incredibly hot. So yeah, so I was curious to know about the color selection and really happy to have that answer.
Yeah, so the second in line is Shep.
Oh, hi. Really wonderful talk, and wonderful to hear. I guess when I think about this and your thesis of movement, I also think of exploration, right? Because the black hole image was secured, through exploration, and we really do think of ourselves as explorers. And Dominic's point about cartography also comes into play, because we really are exploring the unknown. And people used to say there were dragons, and we just didn't go there. And what's the biggest dragon if not the black hole, right? And so there's an element of exploration, and it's embodied also in the fact that we go to the most exotic places on the planet. We have to go up to 16,500 feet, and we have to have supplementary oxygen just to breathe up there. And so there's this idea that we're putting ourselves not really in danger, but we're into discomfort. We have to go off of our couches to make these kinds of images. And then there's this connection also that exploration makes with storytelling, which is such a part of the human experience. And when you tap into storytelling, that makes the full connection with the billions of people on our planet. So not only are the photons making their voyage to us from the deepest part of the potential well through the gauntlet of the interstellar medium and our own atmosphere, just to ding off some piece of metal into a superconducting junction, right? But so they tell us their story, but we're also exploring going to the edge of the black hole. And it doesn't mean anything unless we come back and tell people what we saw. So there's an exploration, which is kind of your movement, but there's also storytelling, which I think is very important for all of us in the BHI too. That's what we do. We kind of tell people what we found.
Yeah, I mean, I really appreciate that comment. And again, it resonates so deeply with exoplanet astronomy. Like the rhetoric of exploration is, of course, all over the space sciences. And I spend a lot of time thinking about what the connection is between the exploration rhetoric in something like human spaceflight and the exploration rhetoric in the space sciences. And like, does it do the same work? And I think that to me was the interesting puzzle about beginning to, having a couple of days of the pleasure of thinking about black holes was, for me, the exploration rhetoric for exoplanet astronomy was very clear. There is this potential of going there. But of course, it's like interstellar travel. So the same potential of going there is actually the same for a black hole when it comes to they're both these imaginative processes. But, from the storytelling angle, I think it's a lot, the storytelling, the story is clearer for exoplanets in terms of what the exploration narrative is. And it's really wonderful to think about how that exploration narrative plays out the imagination of the black hole. So yeah, I just really appreciate those comments and absolutely agree and am intrigued by them.
Javi.
Yeah, I just wanted, oh wait, maybe I'm not, can you hear me?
Yes. Mm-hmm.
Oh, you can, okay. So one thing about the image that I wanted to comment about is that one definition of a black hole is that what you see is not what you get. You know, when you go to a black hole, it's not that image at all. You know, what we're seeing the light that was able to escape, but it comes in a ring much farther from the horizon itself. I mean, it's at for a Schwarzschild black hole, it's 2.5 times the Schwarzschild radius. So it's not the event horizon, actually. We are seeing a ring of light coming farther out. And getting close to a black hole is a completely different experience. And of course, and the interesting question, I was asked this question this morning after the Nobel Prize was awarded. Several journalists contacted me from Associated Press, Scientific American, LA Times, and they asked, why is the public fascinated by black holes? Maybe you can answer that to us. Why are people that are not scientists find black holes so much more fascinating than anything else? I think they find it more fascinating than exoplanets, for sure.
Alas, to the exoplanets' chagrin, although they got the Nobel Prize too. I feel like I have to speak up for my people. I mean, I feel like, you know, Peter offered such a good first go at that, which is that it's the paradox. Well, there's a whole bunch of reasons, right? One is the paradox of the object, which I think if you're someone who's science literate, you'll be immediately entranced by like this unknown. I mean, as a high schooler learning about astronomy, it was certainly the mystery of the black hole that seemed much more alluring than planets, and it at the same time is a little bit more culturally resonant than, say, a quasar, right? Like, we have a lot of popular culture built up around the concept of the black hole, not only because of, you know, Einstein and the imagination of, you know, black holes as wormholes, as these kinds of tunnels, but it's the extremity of our imagination of what gravity is, right? I think that is something that you do get in high school physics, is like, or as was said in the press conference, it's gravity run amok. So it's this thing that we encounter on the daily, but really don't understand, right? We being a very lay public, like, don't understand the implications of gravity. And the black hole is somehow the implications of our lived experience. It's like, this is what it would be if it was taken to its extreme. So, I mean, to me, that certainly seems like the exciting challenge about those of you who are at this institute, which is to understand why there is this public intrigue. Why does the black hole capture imagination in a way other objects don't? And I think we've already heard a bunch of answers to it, given like just the comments on this talk, but what is the story around that? Like, is there a way that also that story of intrigue can be connected to these images, such that when they circulate in the press release, there's the story that accompanies why this is fascinating and compelling? And I mean, my understanding is that's already the work that, you know, those assembled at BHI are doing, and it's why philosophers and anthropologists and historians are welcomed into this space. But the question of what fascinates humans, even anthropologists don't really have the answer to that question.
Well, it's good that we don't have an answer, because that justifies continuing the BHI for a while until we find the answer.
Yeah.
We have a question from Nick.
Hi. First of all, I just wanted to say thank you for the talk. It was really interesting. Your comment on movement I found particularly resonant. The EHT just released a press release about M87 where we used the metaphor of black holes wobbling or black holes dancing. And I thought that was rather interesting that you picked up on this sort of theme of movement when that was like exactly the metaphor that we used to describe the black hole. I wonder if there's something about, you know, so Shep mentioned the idea of storytelling and the journey from the black hole to Earth. I wonder if there's something about the sense of danger, perhaps inherited from sci-fi, you know, the sense of surviving against unimaginable odds at the black hole, this great, you know, dangerous gravitating beast that makes the black hole sort of more understandable or intelligible to people. So some sense of like the black hole is this great thing that, photons or astronomers, explorers like in Interstellar that are near the black hole can't survive it, but if they somehow do, that's some relatable story of survival against odds. And I was wondering if you had thoughts on that.
Yeah, I mean, I think that really articulates what I was beginning to try to allude to at the end of this, like, that escape from the black hole is this reclamation of liveliness, right? So yeah, the black hole, for better or for worse, is somehow equated to death. Like, isn't there a black hole in Star Wars? I don't know, it's been a while. But like, right, I think like that black hole is like the ultimate punishment or something. Like, and it's an imagination of an actual hole, not a black hole in like a cosmological sense. So yeah, it's inescapable, right? If you know anything about a black hole, if you're a layperson, I think you know that it's inescapable. And yeah, it was interesting that you mentioned the wobbliness. I actually had just, that press release came across, was in my email because it was like for some reason, some connection, it came across, and I saw that movement there, and I was very intrigued. I was like, okay, this is about movement. And again, I think to someone who hasn't spent much time thinking about black holes, that was a real fascinating surprise to me, that accompanying the black hole, accompanying this image, was a sense of movement, precisely because I think I had the more pop culture black hole equals death association in my mind. So it just tells something very compelling and surprising about the storytelling that's assembling around black holes as, in fact, this site of intense movement and intense liveliness that's counter to our expectation, which goes back to the point about paradox.
Thanks.
Thanks.
Yeah, so there is somebody else? I have a curiosity, actually. I was wondering if you have ever done like an anthropological study of the ability of what drives people, like in the general public, not scientists, to discern between images and imaginations. So sometimes when we do like public outreach talks, we show, both real images of, I don't know, black holes and stuff, but also like simulations or just drawings, and sometimes people have a hard time to understand which is which, because they don't have the knowledge, the a priori knowledge of the scientist that knows the limitations of telescopes, etc. But some people, also in the general public, they are very good at discerning what is imagination and what is like a real image. So I was wondering if you have any insight about that.
Well, I think the insight is what you've already mentioned, that it's a real challenge, particularly as photorealism computer graphics, thinking about the case of exoplanets, have become practically photographic. And in terms of like the practical conversation, I have like spoken with a lot of exoplanet astronomers about their worry of those, like the kind of the landscape exoplanet pictures, because their worry is the public that glances at an image like that might think, oh cool, we landed on an exoplanet, and then not understand why this science needs to be continued to be funded, not understanding the real gap between the scientific knowledge and the kind of press images that often circulate. And it's why at the beginning stages of exoplanet astronomy, there was such a resistance among astronomers to allow artists to be too detailed in their representation of exoplanets, because they didn't want to mislead the public in terms of what is known and unknown. And at some point, that conservativeness has melted away, particularly in exoplanet astronomy, but not without the chagrin of some of the exoplanet astronomers who would have preferred to like not be seduced by these very beautiful images, and instead to depict something that's more comparable to what is actually known and not known about these phenomena. So I haven't looked at I haven't done any studies about public engagement, because frankly the public is much harder to understand than scientists. But there are people who do particularly research, public engagement, and with things like science images.
Yeah, thank you. We have a question from Martin.
Yeah, hi. These images, artistic renderings can be very formative in scientists' opinions too. There's a very famous image made in a review talk of a torus around a black hole, which is what a quasar looks like. And people have got this idea of a donut around the black hole fixed in their heads because they saw that image. Mm-hmm. And I keep trying to say, don't show that image, it's wrong. But if people keep coming back to it because it's such an evocative image, it makes it very easy to understand what's going on, but it's not really right. And so it works for scientists as well as the public.
Well, and that was the interstellar picture, right? And the NASA simulation, which look eerily similar. And I know that like on Interstellar, there were scientists, science consultants working with the VFX people. And likewise, Chesley Bonestell, the artist I mentioned who did the views of Saturn from the moons, he went on to be a special effects background painter for all of the mid-century sci-fi movies. So, you know, there's this long history of the movement between kind of Hollywood image making and scientific image making, including with Exoplanets. One of the collaborators on the JPL Exoplanets is also a special effects trained Hollywood image producer. And so, yeah, it's really complex, and we're absolutely influenced by the fantastical images we've encountered on the screen.
By the way, there were scientific mistakes in the image that was used by Hollywood in terms of the spin of the black hole and so forth, but never mind.
No, but I'm sure, right? I think there was a long thread by Neil deGrasse Tyson about that.
Yeah, so Lisa, thank you very much. You've been a record breaker, not only the first anthropologist to speak at the BHI, but I think one of with the highest number of questions and comments. We have a lot of comments also in the chat that I'm gonna copy and send you via email. So yeah, thank you very much.
Well, thank you. I have to say I was intimidated to come speak to people who are far more expert in this topic, but I really enjoyed this and so much enjoyed your comments at the end. And I now shall endeavor to find a PhD student who will become an anthropologist of black holes and accompany Tiffany also on her journey in studying this group. So thank you all so much.
Thank you. Bye-bye.
Bye.